So I'm going to be going over angles and triangles, and it was nice because what Dave, when he was doing the cube cutting, talked a bit about triangles. So this is going to be a nice kind of way to lead in and continue with what he was discussing. Okay, why is this not? Oh, there we go. Okay, so as we talked about yesterday, a triangle is a geometric shape which has 3 angles and 3 sides. Triangle. If you add the 3 angles, whatever their measurements of a triangle, they're going to always equal 180. There are 6 ways to define a triangle based on their angles and on the relative length of their sides. Come on, there we go. So if a triangle has a 90-degree angle, doesn't matter what these other angles are, that is a right angle. If all 3 angles are less than 90 degrees, it's an acute angle. And if one angle is more than 90, and of course the other 2 are going to be less, it's an obtuse. So that's one way we can define triangles, by their angles. You can also define them by the length of their sides. If all 3 angles or all 3 sides measure the same, then it's going to be an equilateral. That also means the angles are going to be the same, but equilateral. If 2 sides are the same and one is not, then it's isosceles. And if none of the sides are the same, that is a scalene. So how do we measure angles? This is probably the one you're going to use the most. They're in all the classrooms, and this protractor is just very common. And one thing you can notice about it is that if you have a straight line, what's the angle of a straight line? 180 degrees. So that's why it starts at 180. Right at the middle is 90. That would be your right angle. But there's 2 scales. There's a 0 starting this way and 0 going this way. Well, that's because if you have an angle that goes this way, then we can use, and we know this is not a 90 degree, then we can use the lower number. If your angle if it's a wider angle, then we can go out here. But if your angle goes this way, then you would use the other scale. So that's why it's just set up like that. This is your most common. The thing about this is not all your angles are that long. So if you try to use this, it's going to be hard. What you need to remember is that angles are actually rays, which means the lines, they have a starting point, but they go out for infinity. So if you're stuck with this protractor at school and you don't have another thing, what you can do is either extend the line. Sometimes I'll take a ruler, a piece of paper, and try to extend the line so that I can find the number. What I didn't know, which is really cool, is in your kit, there's a teeny tiny one. And this is good. Hang on to this one. I'm actually going to try and get more of these. We're going to even use them today on the computer screen. There's this other one that I also think is kind of cool. And that you have one in your clinometer kit. This extends the line for you. You line it up, and then this little swinging bar will act as a way of measurement. Now, this is not the best quality. I was playing with it as a protractor. I would not rely on this one. The one here on your screen, you can see that the dot lines up perfectly with your 180 line. These do not. It's really, you could be easily off by a degree or 2. So this is we're going to use for building some equipment, but I still think it's a great concept. There's also circular ones. This is a ruler. So different types of protractors. So we're going to practice using a protractor. And this is a fun puzzle where I wish I had found this before I sent out the packets, and the quality of this image is not very good, so I did the best. But we're going to measure these and we're going to solve a riddle. So what I want you to do is take that piece of paper and make 12 columns. Should have done it this way. 3 across and 4 down. 1, 2, 3, 1, 2, 3, 4. I would have done it the other way, but because what we're going to do is we're going to measure these, and then we're going to remember what the letter is and figure out what the puzzle is. So I know a lot of you have, you're all participating, but some of you don't really do all the activities. So we're going to do all the measurements together. And then if you guys can solve the riddle, I'll send you a $10 Amazon card. So hopefully that'll get you guys to work through this with me. There's 2 ways we can do this. Where'd my little guy go? We can either look at our protractor and kind of get an idea because it's fuzzy. We'll start with this one together. We know it's not a 90 degree, so it's an acute angle, and it goes in increments of 10, 20, 30, 40. So I just gave you that one. So write in your first box 40 R. That way when we get down to the puzzle, you'll know that that's the letter R. But what I found out is, and this is kind of fun, if you want on just a couple of these, take your little protractor, hold it up to the screen, and that's what I mean about these little ones. I can see it's 40. I just verified it. So definitely hang on to this one. All right, so R is 40. This out. The next letter we're going to try and solve for is I. Anybody want to shout out what they think it is? 10, 20, 30, 40, 50. Or take your protractor, hold it up. Yep, I got 50 with my protractor. All right, C, we know that's more than 90 degrees, right? It's past the 90-degree mark. So what does anybody, that's a little bit tougher to count. I mean, you guess you could, because we know that this is 90. That's why I did that little tick there on all these so that you know that's 90, 100. What do you think it is? Anybody want to try with their protractor on this one? Did anybody try? Yes, Naomi, good. 140. Good. So 140 is C. So write that in a box so that we can figure this out at the bottom. Now K in the second row is faced in the opposite direction. So we're going to be counting a little different. You can either use your numbers knowing that this is 90. We would just subtract what? We would subtract 10. So does anybody want to shout out what they think that one is? And I can also use my protractor, but I'm going to use the other side. I'm going to use the top scale on that one. What'd you guys get? What's 90 minus 10?
80.
Thank you. Good job. All right. So K is 80. A, letter A, is almost flat. That is a very wide. And we said that this is, if it was flat, it would be 180. And you can see that it's crossing just 10 above. So we can either protractor, and I can see it, it matches up. What is 180 minus 10?
$170.
Very good. So A is 170. Moving on to M. Here's the 90-degree mark. And is it wider than a 90-degree angle? So what do we think that one is?
80.
It's 90, but it's 10 degrees wider than 90.
Oh, 100.
Yeah, so M is 100. Good, we're halfway through. Oh, Fui, I'm so sorry. Wait, how do I go back? Wow, okay, there we go. What are we on, L? No, I lost my place. Where were we? Are we on E? We're on E. Okay, so we can either start at 90 and count 10, 20, 30, 40, because that is wider than a 90 degree. or you can take your protractor, put it up on the screen. Yep. So what is 90 plus 40? $90 plus another 40 degrees. Thank you. Good job. Naomi, you're doing great. So E is 140. L, does that look smaller than a 90-degree angle? This is a little tougher to count because it's so fuzzy. And also I'll tell you, this was a tough one. I had to use the protractor because I did not believe it. It is actually between 10, 20, 30, 40, 50, and it looks like it's crossing at 50. I'm going to give you guys this one. L is actually 55. And then now we're at U, which is that smaller or wider than a 90 degree? There's your 90 degree mark. So it's a little bit wider. That's 90 and 2 ticks over. Not 120. It's two ticks, 10, 20, 90, 100, 110. There you go. Good. So U is 110. E is also reverse direction, which is fine. And this was also a tricky one. It's just the quality of the image, and I apologize. So it goes up 10, 20, 30, and it's supposed to be actually landing right between 30 and 35. So that's 30 and 40. So it's a 35. Give you that one. P is really short in that opposite direction. You should be able to see it's just probably 1 tick up. Let me put my protractor up and see. Yep. Smaller. It's only 1 tick up. There you go. P is 10. And S, we should know that one on our sleep. What is S? Yay! All right, so S is 90. So now what you do is you find, using your sheet, find which one was 35, which was 110. Not all of them are used. They gave you a couple of angles that did not have, the letters are not used. But can you private chat me if you find the answer so I can give you credit? I don't want someone to give everybody an answer, if that makes sense. Oh, Dave, you're making me hungry. I haven't had breakfast yet. Where am I? Here it is. You getting it? Who's got it? Don't give me the answer, just say I've got it. Where'd that go? Same sheet. Naomi's got it. Remember, it's a riddle. The riddle is at the very top, so the bottom should make sense, but be a little off. Who else? Anybody else besides Naomi? You can just say I got it. You don't have to do a direct chat if you don't want to. Ready? We're fine. We still plenty of time. I can't find where I am. The clinometer. No, actually, I have to do. Let me do this. How are we doing? Good job, Brent. I gotta write this down. Is it making sense? Which one's Brent? Is it one of the two brothers? Mm-hmm. Okay. Okay, thanks, Brent. Good job. Okay, Hashima and Nina. Good. Is that the group? I don't know if Samantha came in too late to do this. Hold on, let me write Hashima and Nina. So that's them, and Naomi. Samantha, if you want, I can try and work with you on this later. I told everybody that's here today that if you can solve this puzzle, that I'd send you a $10 Amazon card each. And if you want, we can text later and figure it out. So we're ready to move on. So good job. I'm glad you did that. And like I said, hang on, I'm not going to lose this. Look how little this is. This is awesome. Oh, sorry, I was talking to Sophia. All right, moving on. Let's see if that's the pen. How am I going to make it move? Oh, all right. So if triangles have the same angles, they can still be different sizes, big or smaller. These pairs of triangles are congruent. They have harmony. They're similar, but they will have different lengths, but they have the same angles, which means we can compare them. So if you know the measurements of one triangle, you can calculate another triangle as long as it has the same angle by using ratios. Engineers often use this to measure things that are too tall to actually get a tape measure. And there's several ways to do this. Some is with math, with measurements. Some of them use special equipment. So we're going to focus on one kind of triangle. Can't get this out of the way. I went outside at 5 p.m. and measured my shadow. Alex took this picture and he cut off my head. So that's my head there, just for fun. My shadow is 129 inches, and I know I'm 64 inches. First question, what kind of triangle did I make? I'm standing tall, my shadow's going straight out. I made a right angle. Okay, so we're going to be working with right angles and shadows and figuring out how they're congruent. So it's a right triangle. Now, if you're going to do this using shadows, it's important you go out at the same time during the day. And why do you think that is? What's in that picture that changes? My height doesn't change. What?
The sun.
Yep.
The sun.
So if you go out very early in the morning, the sun's going to be here, and your angle is going to be different. Your shadow will definitely be longer. If you go out later, it'll be much more narrow. Your shadow will be much shorter. And same thing in the evening. If you go out late in the evening, your shadow will be longer. And that's why you've got to make sure you try and do it as close as possible. So we know the two sides of the triangle of me. I'm 64 inches tall. That is the A side. We know my shadow is 129 inches. And we can calculate this. We don't have to, but we can calculate this. Do you remember what this is? The hypotenuse. And it's just good to know it for some of the other formulas we're going to do. So we're going to start with that. Remember the formula for the hypotenuse. Hopefully you guys have learned this. A squared plus B squared equals C squared. So I am 64 inches squared. My shadow is 129 inches squared, and that's going to be C squared, the hypotenuse. I did the math because these are big numbers because I used inches. And I got a total of 20,737. I need to take the square root of that, and that will give me the square root for C. And C is 144. So my hypotenuse is 144. Now I should be able to determine the height of other objects that are casting a shadow at the same time of day if I can measure the shadow. Several ways to do this. First, you can just identify the ratio of the congruent triangles. My ratio is A over B. This A is similar to this A, and this B is similar to this B. So if I make a ratio of A over B, what I put is A1, B1, and then this is the object that I'm measuring, and all I know is its shadow. So A2, the shadow of B2 I will know, and A2 is what we're going to solve for. You can flip these, but it's generally A1 over B1 is the same as A2 over B2. So I did this. I tried something small first. This is a small little bare porcelain thing that sits out on my porch. And I wanted to start with something small enough so I could measure and see if it was working. So my bear measured a shadow of 20 inches. I stayed the same. I'm 64 inches tall, 129. So my A1 over B1 is going to stay the same no matter what. We're going to see how similar that is to my bear, which is 20 inches. So now what do we have to do in order to, we want A2 to be on its own side. We need to multiply by 20 on both sides. I'm only going to do the writing once because it's already written out. Okay, so that's this on the top. That cancels this 20, that cancels this 20. And now we get A2 is going to be equal to 64 times 20 over 129. And if you play with the math, you don't have to do this. Just trust me, I've done it. But this is recorded. We can, you can play with this to see if it works. But I got 9.9. I measured the bear. I swear he's 10 inches. So it really worked for that moment. Thank you. Now, can they see this because of all this traffic over here? I hope you can. Can you see the shadow with? You can see the shadow, right? I can because all the pictures and everything is over here. Alex and I went out and measured a stop sign. Stop signs are hard to measure. They're kind of tall. But we measured the shadow of 204 inches. So I stay the same. A1 over B1 is 64 over 29. A2 is the height of the stop sign, and the shadow is 204. So we're going to multiply both sides by 204 to cancel this out. And we get A2 is 64 over 200 times 204 over 129. And that gave us the height, A2, 101 inches, which is about 8.5. And we tried measuring it, and we got about 108 inches or 9 feet. So we were off by maybe about 5 inches, which is not bad. Now I measured something that there was no way I could get that tape measure up. That's me hugging a saguaro. We measured, this was a very difficult one to measure because it was 400 411 inches, we think. We had to, what we did was we started at the base of the saguaro, spread out the tape measure. You guys have a tape measure in your kit also, but it doesn't go 400 inches. So we'd spread it out, mark where we finished, pick it up, add it up, and that was our best estimate. The ground was pretty flat, not perfectly flat. That's another thing that can change your shadows. So in estimating the saguaro, A1 over B1, 64 over 129, my height, my shadow. A2 is the height of the saguaro, 411. You guys want to try the math on that one? Multiply both sides by 411. What do you think you get? While you're working on the math, I'll show you what we got. I can't, how do I move this?
Click on the.
I can't. No, I need my notes because I can't see. I think we got 204 inches. How do I do it? Hold on just a second. Sophia's helping me. But it's on.
Are you on Amazon right now?
I'm on pen.
Oh, then I don't. Oh.
There, okay, that'll be great. Okay, so we got an estimate of 204 inches or 17 feet, which I have no idea how right it is, but we know I'm just over, barely over 5 feet. 5, 10, 15. So this guy probably is close to 16 feet or more. So even with how difficult the shadow measurement was, it does pan out. Obviously, the shorter, if you can, we should have gone out a little earlier and our shadows would have been shorter. Okay, how do I know? Why is it not moving? There, okay. So I can't do this. How do I move it? Let's just move it on top of the pictures. Okay, there you go. I'm just put it over there. That'll be fine. No. Oh yeah, that's true. Shoot. Okay. So now we know how we can look at congruent sides, but it would be nice to learn how to measure angles. And this is going to get a little advanced, but it's still fun to know about it. First of all, we know the sum of all these angles are going to be 180. And this angle, even though this triangle is smaller than this one, the angles, the red angles and the green angles should be the same. Oh my God, there we go. First, don't worry about this yet. We know, let's say we're taking side A is 3, side B is 4, it's a 90 degree. We could figure out the hypotenuse. We've done that. A squared plus B squared plus C squared. This is kind of easy. 3 squared is 9. 4 squared is 16. So 25, we take the square root of 25. C is 5. That's our hypotenuse. This is more advanced, 10th grade, 11th grade. Algebra or trig?
Trigonometry.
Trig, okay. SOHCAHTOA. SOHCAHTOA. That's you stubbed your foot and now you got a SOHCAHTOA. But these are the ways you can use sine, cosine, and tangent to determine the same angle. This is all for one angle. It just depends what sides you want to use. So I did them out of order for this one. If we're going to start with the green arrow, and we're going to take the tangent, TOA, what you're going to look at, O is opposite. So what's opposite to this angle? 3. Then A is adjacent. What's adjacent to this angle? 4. H is hypotenuse. So we would take the tangent of the angle is 3 over 4. But we don't want the tangent of the angle, we want the angle. So what you do is you divide by tangent and you end up with inverse tangent. And if you remember that from the calculator yesterday, what you would do is you would, if you want to practice, you can take out, we'll just do it for one. you would, you would say shift tangent parentheses, because now we're going to do the formula, 3 divided by 4, because this is a fraction. So remember, fractions are division. Hit your parentheses to end the formula, and 36.8. So great, we can do it, but are we sure that we get it right? Well, let's check that same angle with SOH. So the sine of this angle is going to be the opposite, 3, over the hypotenuse, 5. So the sine of the angle is 3/5, 3 over 5. We rearrange this so that this angle is inverse sine times 3/5, and we get exactly the same number. And then just to be complete, cosine of the angle is the adjacent over the hypotenuse. So cosine 4/5. So we'll get angle with the inverse cosine times 4 divided by 5, 36.8 works. You'll see this formula a couple times, but remember it's SOHCAHTOA. So we know the green angle is 36.8. We could take a quick shot at it. We know that the sum are all 180. 180 minus 90 minus our 36.8. That red angle should be 53.2. Well, let's see if the math works. We're going to do so. Sine of the angle, the opposite of the red is 4, and the hypotenuse is 5. So if we rearrange that formula so that the angle is the inverse sine of 4 divided by 5, 53.2. These two just didn't perfectly work out. Cosine, COA. Co for the adjacent of the red is 3. The hypotenuse is 5. So the cosine of the angle would be 3 divided by 5. Rearrange that so that the angle is the inverse cosine times 3 over 5. I got 53.1, so a little bit off. It might be something didn't round up, but and then the same thing happened with the tangent or the TOA. So tangent is the opposite, 4, over the adjacent, which is 3. Rearrange it, you get the inverse tangent is 4 divided by 3, 53.1. So really, really close. We're going to kind of wrap up with equipment that engineers use. So now we're not doing the math anymore. These are, well, we are going to use math, but these are the equipment that people get the information. We're not doing shadows anymore. That's what I should say. A clinometer is a tool that's used to measure height from a distance. And you've probably seen engineers on the road, and they're measuring if there's an angle to the road. They can measure for great distances. There's a handheld one that I know they use it. Forestry people use it in order to measure heights of trees. We're going to make a really primitive one. So get your kit. This is your kit. It should have the swinging protractor. This one's sticky. Where's my other one? I don't like this one. Well, oh, it's down here. No, there should be another one. So we're going to make this. Here it is. Your swinging protractor. You should have a straw, and you can. This is what you're going to look through. That's your little telescope. Should have a piece of string that has a weight on it. And that's really all you need. So if you want to, well, there's a little piece of tape on that. If you want to try and quickly, we can put these together. What you do is you hang, how do I do it from the end? On these, they have a little gap at the end of the swinging part, and you thread the string through there. You don't want it hanging too low. This is a really long piece of string. You don't want it more than like that. And then you just tie it on. And I'm going to show you how to use them using pictures. need to cut that string, but you can see, but the weight, how this is going to swing. Can you grab a scissors and my tape for me from the desk behind me? And if you have tape, what you're going to do is you're just going to tape this along the very top. Turn that around. Because this is going to be your eyepiece. I was playing with this last night. It's kind of fun. So I just wrap it around, but definitely don't interfere with the swinging part, the pendulum part. Okay, turn this around. Thank you. And this, my extra string's just a little long, so I'm just going to cut that, but this is stuff you can do later. And that's it. We have the clinometer. I'll give you a minute or two to finish that up, and then I'm going to show you how to use it. We're good. I only need like 5 more minutes. Also in your care package, there was a handout. Obviously, this lecture has changed a lot because I reformatted it that we're not going to go outside for any of this, but a lot of the formulas are in here. Again, this is recorded, or you can text Sophia. She knows this better than I think she retaught me half of this, so she knows all this. So for the sake of time, you guys can keep working, but let me just kind of give you an idea of how to use it. I'll give you another minute. I can see you're still working on them. Mouse, why? I don't see her name.
That's because you don't see everyone.
Oh, well, did she get it?
No, just bring me right more people down. That's why I put her down.
I'll have to ask her if she got the message, if she got it.
See, she's been participating.
Okay. All right.
Yeah.
Okay. How we doing? Feel good with it? I forgot to include the tape, but what you can do, I'm going to show you how to use it. You can,
Around the coin.
well, it was around the coin, but there was some blue tape around. There was a quarter. Remember when I did the reflection and refraction? And I said, you can put a coin in some water, and you have to tape the coin to the bottom of the cup. So you could use that. That wouldn't be a problem, but you don't have to do the tape today. It's very simple how to use. And then you can just, after this program, you can go find something sticky. Sorry about that. I was the one that put the care packages together. It was a lot. Well, that's right, you did. Well, why didn't you put tape in there? Yay, good job. That looks great. All right, so let me show you how you do. Oh, good. Yeah, cut your ends off. So what this is you're going to look at it like through a periscope. And you want some distance. You don't want to be close. But what you're doing, you can see down. Can I have the mouse here? You've got, for this example, you've got a guy who's looking through the clinometer. He's trying to measure the height of a tree. Well, your angle, it's a right angle, right, with the tree, because here's the side, this is the hypotenuse, this is the distance, but you're only measuring for this part of the tree the height from where you're looking. So when you're doing this, you're going to have to take in consideration how tall am I to my eyeball. So you give some distance between you and your object. If you're too close, you won't be accurate. You obviously don't want to be too far away, but 20 feet, something like that. You look through the straw, and the straw is going to hang. It should hang. And then what you do is you kind of just pinch that pendulum part, and then now I can see where the angle is. Mine says, what does it say? Mine says 70 degrees, but it's not 70 degrees. It's 90 minus 70 degrees. That's your angle of elevation. Now you want to determine how far the object is. You really do that. You need to know the distance, because you have to have that angle and you have to have a distance. If you have those two, you can get your information. Again, if your tape measure is not long enough, what I've done is I measured my foot and I kind of did a steppies. I took a long piece of string and I measured how many times I had to move the string. I mean, you're going to guesstimate. We're obviously not building buildings with this yet. Finally, you need to know your eye height. So measure from your feet to your eyes and get that as best you can. Oops, why isn't it going? Okay, there we go. So you've determined your angle of elevation, and we know the distance of the adjacent line. This guy is measuring a flagpole, and he's using that same clinometer. We're going to use the tangent angle. If we know the angle of elevation, opposite over adjacent, TOA. So I practiced with a building roof. I did this yesterday. And the angle on my clinometer was 60 degrees. So 90 minus 60 is 30. 30 degrees is going to be my angle of elevation. And I did my best to measure. I was 22 feet away. My eye level, I had to measure myself, is 4.7 feet. Now I'm doing it in feet because these are such big distances. So TOA, tangent of 30 degrees, times the opposite, which is my height. What did I say my height was? Oh, we don't know the height. And the distance away is 22 feet. And if you do the math, actually this one now you do take the tangent of the angle. So the tangent of the angle is 0.57. Now I'm gonna back up, sorry. I'm looking for the height. I'm not looking for the angle. So now I have to get this 22 over here. We're gonna multiply both sides by 22. Ugh, I'm not a good writer. That'll cancel these guys out. 22. So to simplify, the tangent of 30 is 0.57. It's supposed to be 22. Times 22 is 12.5 feet. Now I have to add in my eye height, which was 4.7. 12.5, 4.75 is approximately 17 feet. We estimated the height of that roof was 18 to 20 feet. We're using a very primitive instrument. I didn't do good measurements, but not a bad try. Okay, so I hope you had fun with this. Try different ways of measuring things, some that are smaller than you, some that are taller than you. Try using these formulas, see what works, what doesn't work. The smaller you can verify if it's working. The taller, you kind of have to guesstimate if it's working. So I hope you had fun. Is Dave still on? Because Michael had a riddle for you.
I am on.
Okay, what do you get when you cross a mosquito with a mountain goat?
Mosquito and a mountain.
You can't cross a vector with a scalar.
Okay.
the mosquito is a vector of disease.
Yes, yeah.
And the scalar is a mountain goat going up and down the mountain. So that was from Michael, who is at work. Guys, I really loved working with you. I'll sit on the rest of the sessions, but I hope to see you all next year. Please text, email if you have any other questions.